graduated in 2015. And I work in a company called AI Energy Analysis. And I will tell you a little bit about what I do there, and it's mainly about power system modeling and international cooperation. So a bit about me. I'm from Belgium. I have a background in engineering. I studied in the University of Ghent, applied physics, and then I did a master in photonics. And in my last year of this master, I really wanted to leave Belgium. And I asked my professors what is a good university to go on Erasmus on for photonics specifically. And they told me DTU, so that's how I ended up here. So I had a really great year, Erasmus year in DTU, very fun. I met a lot of nice people, had a great time. And I was allowed to have 2 electives that were not related to my actual master, which was photonics. And one of the classes I took was modeling of sustainable energy systems, which was then 10 credits course, which I really liked, and it kind of introduced me to this master that I now took. So I got really inspired by it, I really liked it, and I ended up taking the master afterwards. I did the wind study line, which I'm not really very much related to anymore. And then during this master, I did my master thesis with the AI energy analysis, and that's how I ended up there. So I did my master there using Balmoral, which I will talk a bit more about later. And then after this thesis was over, they hired me, and I am currently still hired there, which I'm very happy about. So I will talk a little bit about this company. It's a small consultancy in Copenhagen. It was started in 2005. It's located in Copenhagen. We just moved to new offices. We have this view from our new balcony over Gammeltorf. We're usually around 25 to 30 employees there. We're currently in the process of hiring some new students, so we'll grow a little bit. And in general, in my opinion, it's a really fun, exciting place to work. Very early on in the hiring, in the time that I worked there, I got a very high level of responsibility. They were very kind of keen to give new employees a chance. And you have a lot of flexibility, and there's good social environment, work-life balance, all that. So what does AI energy analysis do? Well, they basically do energy analysis. We do modeling of power and district heating systems. We do modeling of gas systems. We do analysis of the energy markets and of the regulations in the energy systems. On the right, there are some of our clients. In general, we do around 2/3 of our projects are Danish, about the Danish energy, power, district heating markets, and then around 1/3 are international projects. This varies from the moment you will ask us, but in general, that's kind of the ratio. For the international projects, it's often Danish Energy Agency who is the client. And that brings me to what I do there in this company. As I'm not Danish, and I don't speak Danish very well, I am not put on the Danish projects for not being able to write Danish reports. So I'm mostly on the international projects, which I'm very happy about. And most of the projects that I do are involving this model Balmoral, that is, I think, also known by most of you. It's used very often in DTU. I started using Balmoral during my thesis, so I got introduced to it then, and then I kept using it after. I would like to explain a little bit for those who are not very familiar to it. It's a model to analyze the power and district heating system. It's kind of the model is a least cost optimization model, so it will try to find the cost optimal solution for any situation. It's doing that by optimizing the generation, dispatch, and the transmission flow in an existing or in a system that you input into the model. And then at the same time, simultaneously, it optimizes also new investments to kind of supply the new demands in the future. So it's kind of a good model to do scenario analysis. A bit more about it, it's an open source model. It was developed around 18 years ago by Hans Raun from DTU. And in the meantime, it has had many users, DTU, research institutions, private companies like us. And they have continuously been developing this model, so it's been improving over the years. This is kind of a graph of where AI at least is using this model. So you have Europe, we have Balmoral in China, Indonesia, Vietnam, East Africa, PowerPool, Egypt, Canada, and Mexico. So we are using this model in many places in the world. And I will just show some examples of projects that we do with this model abroad. So one of them is Vietnam. I'm currently working on a project in Vietnam. In fact, I'm leaving tomorrow to go there. What we do there is we provide input for their energy outlook report. We did that last year. We are doing it again for the new energy outlook report. And we usually do all kinds of scenario analysis. They're still developing the ones that we are doing now. But this is for an example in the graph on the right, where we are comparing their current RE targets. So they have some targets of how much of their energy mix they want to be renewable. And we are comparing that, so this RE target, we are comparing that to what if they put taxes on CO2 emissions instead. And then from the graph you can kind of hopefully see that as they have a very coal-based power system, it's one thing to have a lot of coal and then put RE on top for the remaining share. And then if you have a CO2 tax, you would probably first look at the fossil fuel-based generation, try to reduce the emissions there, and then additionally add RE. So it's kind of a different approach to reducing emissions and to be more sustainable. Another part of this project is where we try to combine Balmoral and Times, which is another model, and this is a cooperation with DTU. And then on top of that, we also do training locally in the Balmoral model. So there's local consultants, PhD students, some people from the TSO that are learning how to use Balmoral. And that kind of, one thing is that they could use it, but the other thing is that they really understand the results. That's the kind of one of the key messages. So we have both analyst trainings where we go through the results, we show them how Balmoral works, what we are expecting from it, and then we have operator trainings where we actually try to teach them how to make these scenarios themselves. We do something very similar for Mexico. I just say we provide input for the renewable energy outlook. Mexico is a little bit different from Vietnam. They use the nodal pricing system, and they have very detailed information about their country. So instead, in Vietnam, we use 6 regions to model the whole country, while in Mexico, we use 53, so we have a very detailed model. In the latest report, we took a look at how ambitious their current targets are, and on the slide to the right, on this graph, you see that. So this is a comparison of the share of renewables in a scenario where we implemented this restriction. So the model was forced to have a certain amount of RE in the system, which was the one that is their current policy. And in the unrestricted scenario, that's a scenario where the model was just allowed to optimize according to market, let's say, without any restriction. And as you can see, the results are very similar, kind of indicating that their ambition, like their targets are not very ambitious. We would get there anyway, is kind of the message. Limpia means clean, so early. And then again, we do training also in Balmoral. Then another project a bit closer to Denmark was a project in the Faroe Islands. Faroe Islands is an islanded system, but it's also very far from from mainland. So there's no option of connecting to neighbors or anything like that. And they have a goal for being 100% renewable by 2030. They mean the power sector, but they also have very ambitious goals for electrifying heat and transport sector. So it means 100% renewable in the 3 sectors. That's the scenarios we're analyzing. And what they have as resources, it's kind of an island where the forces of nature are very strong, so they do have some renewable sources. They have a lot of wind, very, very strong wind. They have hydro. There's option for tidal in the future. They can of course install solar panels, but it's not the best place maybe. And what they don't have is they don't have fossil fuels. They don't have biomass locally, domestic. And importing anything is very expensive because the shipping is far. And they, of course, don't have transmission to neighboring countries. So, with all this variable renewable energy, their kind of only option for balancing is pumped hydro. So we developed the Balmoral model to being able to optimize this kind of system where you have a hydro reservoir in the top, a hydro reservoir in the bottom, and then a pumping system here, and turbines kind of here. This is kind of a cascading hydro setup, and the model can then optimize increases in reservoir sizes, increases in turbine sizes, and then increases in pumping. So we're looking very in depth of how pumped hydro could help their power system. This kind of last slide, it's not with Balmoral, it's just about our international experiences. And I stole this slide from my colleague who did the same presentation last year about how the 2 of us were sent to Morocco to give like a full-on 2-day workshop in solar PV integration into the Moroccan power grid. And we were supposed to do that in French, and we are both not French-speaking at all. We have our high school French, which we repeated many times to each other. So this is kind of an example of this. You get a lot of responsibility in the beginning. Yeah, that was exciting. So, and I think it went sort of okay. I think they understood us most of the time. So as conclusions, I think it's very interesting and fun to bring this Danish knowledge that we think is so, like for us, it's so normal by now, like all these same things like integrating and transmission, that it's very important. This is not so obvious sometimes when you go far abroad. Of course, if you go to the Netherlands, maybe it's fine, or in Germany, they all know this. But yeah, I think it's really fun to bring this Danish knowledge abroad, and you can also, I have the feeling that the impact you can have by doing that, it feels like you can actually have an impact. Another conclusion I would have is saying that working in this kind of international projects, there's also many challenges, cultural, organizational. It's not always the same working culture. It's also just interesting to learn about how the power system works in other countries. I know Mexico has a very advanced auction system with technology-neutral auctions, which was very interesting to study as well. And then yes, just in general, that modeling future power systems are a very good tool to make informed decisions for the future. That was it. I don't know if there's questions.
Hello. I I was not very aware of the Balmoral system from before. I have missed that. So I just wanted to ask, what is like a typical customer? Is it the government itself, or is it more like private companies?
Yeah, it's so the actual client for those projects, many of those, is Danish Energy Agency, and they have a cooperation with foreign agencies. CENER is Secretariat d'Energia, something. So we work via the Danish Energy Agency with them, and often there is also subcontractors, kind of. For example, in Mexico, we're working a lot with the Mexican university, the students, because they are contracted by this CENER, the Mexican Danish Energy Agency. And in Vietnam, we're working with a local consultant, so we're teaching them the model because they are going to be working for the Vietnamese government, basically. Yeah.
I can do it without the mic. I think it's okay. Not so many. Can you hear me?
No, we need for the video.
We need for the video. Yes.
All right. Yeah. So I'm also aware of the Balmoral model. I know it from the university setting. I've also heard it's being used quite a lot in a professional setting. So I'm just curious, when you go out to the customers as a consultant working with Balmoral, selling your product, and then they ask you the question, so how do we know we get accurate results? How do you reply to that question?
How do we know if we get accurate results?
Yeah, how do you know that Balmoral creates the results that are accurate?
Well, one thing that we often do is we just show them the model. If they have some background in coding, they can go through it because it's kind of open source. You can just look through the codes. Another thing is that the other thing is that we really try to focus and kind of emphasize that you get the results that you give the model. Like if the input data is good, you're going to have accurate results. If you don't give good input data, then the results are not going to make any sense. So we really try to explain very well what is our assumptions, what is the data that we feed into the model, and then we have a lot of kind of back and forth with criticism, feedback, how should we update it, and then it's just up to trusting that the model works, I guess, yeah.
It's just also a comment on that point. I think I'm not really familiar with Balmoral, but in Danish Energy, we also have some people working with Balmoral, and I think that's one of the forces with Balmoral, that you use the same engine you can take to build up different models of different regions and a lot of inputs from different sides. And again, we as a trade organization also use the services of the energy analysis for different projects, not just Balmoral because we have our own model, but other areas. But again, I think one of the forces is that it's really broadly used by a lot of different organizations. So you do the decentralizing, all the debugging, you can say.
So, kind of to iterate on the same topic, I was wondering, do you think it's actually feasible to teach? You probably do, but I would like your opinion on this. Do you think it's easy or feasible to teach people to use this Balmoral tool without them having a background in linear optimization and without actually understanding the engine? Or do you give them a background in linear optimization beforehand so that they can understand what they're working with?
We do a short introduction to linear optimization, but it's a very short and brief kind of, these are the equations. I think it's very feasible for them to use it, to work with it, to make analysis with them. I don't think without help you can get very far. I mean, it took me many years to get very kind of advanced in this model. I don't think a week workshop will get you to the same level, that's clear. So I think while, operating the model, it's very useful both because you learn how to use the model and you can make analysis. In Mexico, the university student made some of their own analysis where I was not involved. I think they did get some help from Amalia, who is there and is also very expert in Balmoral. So they do use it and they do make analysis, but I don't think they could not set up a model in a new country like that. That I don't think is feasible. But another part of being able to operate or starting to learn how to operate is also a deeper understanding of the model. And I think you can talk on a high level what you want. If you've never operated the model, you're never going to get the same deep understanding of how the model works.
Totally agree. And just to understand, do you usually sort of teach them how they can, for example, extend it? So if they have a new power plant that they have to add, or if they have a new type of technology that they want to add in, do you teach them how to do that? Yes,
definitely. That's not very advanced Balmoral usage. Adding a power plant, it's very easy, and that's kind of in the standard set of things we teach them. We usually divide Balmoral knowledge levels or skill levels into 3 sections. We have the analysts who just kind of are focused on the results. They need to understand the kind of analysis you can do with Balmoral and what are the options, is the spectrum and how to interpret the results. And then you have the operators who use the model and who really just input data, get the results, also analyze. And then we make like a 3rd level, which is the programmers, and that's really the developers of the model. And we never teach that. So that's kind of the part where that's EA usually. If they have any questions, we're always very open and flexible in developing the model. But for teaching that, I think you have to have a very high level of understanding and skill level. Yes.
One last question. Yeah, maybe a comment.
Right. So maybe I don't disagree with what you're saying, that it's very good that we use this model in a lot of places, but I'm curious about, you could say, quality of the results.
Mm-hmm.
So I'm just curious, do you do validation of the model as you go? Because you have a lot of